What up, guys? This is Mr. Herb back at it. You got 5 minutes? Good. So I can show you some more about these reflections. Now, last time we talked about reflecting across axes. This time we're talking about reflecting across the origin and a different type of line, a diagonal line. Now, the origin, this is probably the only time you'll hear about reflecting across a point, but you might be asked to reflect across the origin. Remember where the origin is? Oh yeah, that point right there in the middle. So to reflect across the origin, it's just as simple as counting spaces. Yeah, let me show you what I mean. I'm going to start at point C, and I'm going to count spaces it takes to get from C to the origin. Now remember in our other reflections, the reflection is the same distance from the mirror as the original point. It's going to look something like this. If I count C, from C to this origin, I'm going to go over one space and down one space to get to the origin. I'm going to repeat that motion on the other side of the origin. So I'm going to repeat that over one, down one, and there I have C prime. Yup, exactly right. And I'm going to do the same thing for the other 2 points. So starting at A, to get to the origin, I got to go over 1, 2, 3, and then down one. I'm going to repeat that motion over 1, 2, 3, down one. Yeah, and there's A prime. I'm going to do the same thing for B. Ready? To get to the origin, starting at B, I go over 1 and down 1, 2, 3, 4. Guess what I'm going to do now? Same thing, over 1 and down 1, 2, 3, 4. B prime. Yes! So I've reflected each point across the origin. Now just connect the dots. Good. I have reflected this across the origin, and now this is done. You'll learn in rotations, this is the same as rotating 180 degrees, either way, but we'll get to that later. Let's talk about this other type of reflection. Okay, here's another type of reflection across the line, y equals x. Now, y equals x is a line that goes through the origin with a slope of 1, so it looks just like this 45-degree angle diagonal line. Now, this is a different type of mirror because the mirror is slanted now. So when C looks at its reflection in this mirror, it's not just going to be directly on the other side because the mirror is slanted. So what that means is C's reflection in this mirror will actually take a turn down. Yes, just like this. Still the same distance, but the distance is in a different direction. This is what I mean. If I count 1, 2 spaces from C to the mirror, right, then I'm going to count its reflection down the same amount of spaces, just like this. Over 1, 2, down 1, 2. And that's exactly where C prime is going to be. Good. I'm going to do the same thing for point A. Let's count those spaces. Now I'm going to the right. 1, 2, 3, 4 spaces to the right to get to the mirror. And then I'm going to turn just like the mirror does, down. So 1, 2, 3, 4. A prime. Just like that. Same thing for point B. I'm going to count the distance to the mirror, but then I'm going to turn because of the diagonal mirror. Count the spaces to the right, repeat the spaces down, just like this. 1, 2, 3, 4, 5, and then I'm going down. 1, 2, 3, 4, 5. B prime. Yeah, connect the dots. Let's see what this reflection looks like. Good. It's almost like I took my paper and folded it this way, and that's where the reflection comes from. Yeah, look at that. Take your paper, fold it over and have diagonally like that, and your triangle is reflected. Okay, now you can also do this without a graph. Let's give some coordinates to A, B, and C, and I'll show you what I mean. Okay, so if you're given coordinates, there's a real quick and easy way to do this without using a graph. Yeah, so these are my original points for A, B, and C. And to reflect them across y equals x, this is pretty big that it says that y equals x. If those two are equal, then that means they're interchangeable. So what I can do is just take this x and y and switch them. Just like that. Now, notice, I took my x and y and I switched them, and that gives me A prime. So is A prime at positive 1, negative 3? Positive 1, down 1, 2, 3. Okay. Does it work like that for all of them? Switch this x and y. Yeah, it's B at 4, -1. 1, 2, 3, 4, down 1. Okay. Last one, C. Switch them. +1, -1. Yeah, man, I hope this helps. And now, if you ever have to reflect across y equals -x, it's the same process on the graph, but your mirror will go like this. Man, I hope this helps. If you need some practice, let me know, and I'll see you there. Next is rotations. Bye, guys.